Ladies and gentlemen, dear colleagues, I would say I'm sitting in St. Petersburg, so here's afternoon. I guess also afternoon has started, at least in Berlin. And for those of you participating more from the Western coast or from the America, then good morning. It's my pleasure to host you today for this session with the topic number 3 about water reuse cases in tourism, rural development, and agriculture. My name is Christoph Rupschat. I'm chairing this session, and I'm the chairman of the working group for agriculture irrigation at German Water Partnership. And I also serve day by day as managing director of Eclarion Consultancy, which is one of the co-organizers of this conference. Within our agriculture irrigation group within German Water Partnership, we regularly meet and discuss joint projects. We're about 30-40 companies sitting together at the moment, mainly virtually sitting together. And yeah, we are exchanging on developments and markets for water reuse in agriculture, irrigation, and also, of course, on irrigation topics. So we thought it's good to join this wonderful event, and I have asked 2 of the founding members of this working group, which we founded about 2 years ago, Thomas Gesta and Parsa Rasavi, to join me and to give us their view on this topic. So thanks a lot, Thomas and Parsa, that you made yourself available, and you will present us your ideas on the topics. We will start with Thomas, and then Thomas will present us his views from ATB, and it will be followed then by Parsa, and together they require about 30 minutes presentation. So I would suggest that that you both present first, and in case questions arrive during their presentations, please be so kind and write them in the chat. And at the end of the presentation, we have then 15 minutes left to go over your questions and raise them to Thomas Gesta or Parsa Rasavi. So then we will start with Thomas. Thomas, a quickly introduction about yourself. You are you're a civil engineer with a construction degree, and you are since 1989, you are working in the domain of small and small-scale wastewater treatment plants, starting as an executive assistant and then becoming technical general manager, head of special projects, and in 2 different companies. In ATB, you are positioned there since May 2002 as head of export division, which you run until December 2020. ATB, as you will also present your company, I assume, is a specialist for development and production of decentralized and semi-centralized wastewater treatment plants. You are also a member in several committees, and many I can see here on your CV. I will not mention all of them. Since January 2021, you are head of special projects and networking at ATB Water. Thomas, thank you so much that you share your long-lasting experience from us. The floor is now yours. Please present us your experiences and maybe also some projects when it comes to water reuse in agriculture, tourism, and other rural uses. The floor is yours.
Yes, thank you, Christoph, for your very nice introduction. I will share my screen with you so that I can start my presentation. Yes, my name is Thomas Gesta, as Christoph already told you. My topic is today a little bit here to give you some examples of wastewater reuse applications which we have executed by ATB. And allow me please a short introduction of ATB. ATB Water is a company which was founded in 1999. It's family owned, a typical small and middle-sized German company. with about 100 people now in total, distributed on the headquarters in Porta Westfalica. And a lot is also decentralized, like I working from home office, not only because of Corona. This is also a philosophy from ATB. And we are a company perhaps a little bit different to the ones you will see during the whole presentation and here, because we are a company which is doing decentralized, semi-centralized projects, and also sometimes not with high-tech solutions. Sometimes it's perhaps better that you have a little bit de-engineered products, especially when you are working in decentralized and semi-centralized fields, because you not have always a well-trained and very well-educated staff people on site. So our philosophy is to do innovations with simple products which can be used nearly everywhere, and solutions not only for the purification, also for the reuse of wastewater, the topic from today, this in technical or also in combination with natural systems. And so our today's portfolio is the development, production, and distribution of fully biological small-scale wastewater treatments, and also of small wastewater treatments. We also make the technical equipment for bigger plants, and for Germany we have a precast concrete company which produces multi-chamber tanks and collection tanks, and also we have a shop with accessories and spare parts, also as an internet shop, and we are doing service and maintenance by a laboratory. We have more than 4,000 service contracts, not only in Germany, also in Belgium and in France. So let me tell you a little bit about the topic centralized, decentralized. As you know, as you see here, I will try to change my. So you see here, you have a classical centralized system. You have here a village or a town, a lot of buildings. The buildings are connected to one treatment plant. You see here in the red circle, and you have a lot of piping, a lot of network where the wastewater is collected and brought to the central system. Here you have an alternative. So you see there's not only one treatment plant, you have several smaller treatment plants, and the water is collected from several buildings or from several houses to several treatment plants, which are then smaller ones. You see the piping here is smaller, and in the view of reuse, please think also that in reverse, also the distribution piping then will be also smaller. The big advantage of these decentralized systems is that you can adapt to really individual circumstances and conditions. You have moderate influence on the local conditions. You have lower costs, investment costs, and also operation costs compared with bigger systems, if you include in all costs also the piping. And you have a very good acceptance of the people because they are living close to these systems. And this is also important for reused topics, because if people see what is happening with their wastewater, they know much more about water, wastewater, and the reuse. And this helps a lot for the acceptance. This is our experience from such projects. Here now you see the change of another extreme. So here you don't have clustered systems. The extreme could be that perhaps building complexes or each house also has its own treatment plant, but this depends on the local circumstances. We are talking about population density and also about topographic conditions and similar. So it's very good to have such a decentralized system if you want to integrate also the population into deciding processes, and it's much easier to convince them. Here are some processes. I don't want to go into details, only a rough overview. You have here a typical gravity flow system with a readback. First of all, a primary mechanical treatment, the biological reactor, and at the end, the collection of the treated water. The same here with the gravity flow system, also primary mechanical treatment, biological reactor, and final settlement. What is the difference to an SBR system? SBR systems don't need a separate decanting place, because this will be done at different times and not at different places. So that means we have less footprint. We are able with this system to realize all geometries of tanks. And SBR systems have a wide range of controlling, of adapting to different circumstances. For example, different conditions in the view of a day, of a week, of a month, of a season. Very often you have very different inflow conditions. And I'm not talking only about hydraulic conditions, also about pollution conditions. And that's the reason why we are preferring this. We are working with modular systems. That means each project or each plant is individual, but based on modular systems. That means we have very short realization times, very short delivery times. And at the end, we have now nearly 25 years of experience with SBR systems in such smaller applications. I want to bring to you now some examples, which I think are interesting and a little bit also typical for the topics we want to bring to you here. You see here a nursing home in Mexico City. You will perhaps ask why in Mexico City? Yes, but please think Mexico City is located at about a high of level of more than 2,000 meters, and drinking water is very precious. You can imagine pumping such a groundwater from more than 2 kilometers below is very expensive. And here, this nursing home has a concept that the older people are living here. And one of the concepts is that they can walk through the park during the day and like to see a little bit of plants and a little bit of green. And they were asking about a concept where water can be reused to irrigate this park. The solution here was to have an inlet of the wastewater, which will be here treated in a mechanical way, a primary treatment, where the primary sludge will be held back. Then the water will flow into a buffer, which will balance hydraulic and also pollution peaks. The water is let into the SBR tank. After the SBR process, it will come into a store tank. And from this store tank, it will be pumped on a reed bed. And the outflow of a reed bed will come here again in a pump sump, which can also be used for recirculation. But at the end, we noticed that the quality of the water, because it's a typical classical irrigation where the water will be distributed in the park, and to be sure that there is no influence on the older people, we have added an additional small UV light system for disinfection. And this looks here very nice. If you have the view from above, you see here in front our SBR system, which is below the lids here. And then this is the reed bag, which is integrated into the park. And if the lids are closed, nobody notices that there is a treatment plant and reuse. Another example is a touristic example on the in Puerto Ayora on the island Santa Cruz in Galapagos. And tourism has increased a lot in the last years in Galapagos, so that a lot of guest house, hotels, restaurants has been opened. And it's a question of, yes, pollution of the ocean. And the Hotel Fiesta is located at the end of a bay. And there was noticed that the biodiversity decreased rapidly and very evidently. And so the hotel had to do something. And the special conditions here in Galapagos is also that the ground is of lava, and the lava is so that water can flow through the lava very quickly, and it's not filtered or similar. So this is the first disadvantage. And you have a lot of basaltic basaltic components on the lava, that it is so strong that you are not able to build pipes or similar. So you have to realize decentralized solutions. And the hotel wanted to irrigate the surrounding a little bit more to have it a little bit nicer. And so the solution was to put in here 4 different tanks, 2 tanks of about 5,000 liters. You have here a first decanting and a rated tank. So with the aeration, we already start to minimize the carbon in the wastewater and to avoid smell. In the second one, there is an additional settlement process. Then the water will be led to a buffer, you know, from before, and then to a biological reactor. And after this, it is brought to a UV light system and into a tank where the irrigation can take place with. The next picture is not so nice, but it can explain how it works. You see here the hotel, you see here the pool, and you see here a terrace where people are playing table tennis and billiard. And the system is here below. So you see there is no influence here on the touristic daily business. And here this way will lead to the bay. And you see here they already started to plant new plants to have a nice surrounding of the hotel. The next application was in the frame of a GIZ project. It was the headquarters of the Jordanian police, which is in Mukabalan, which is close to Amman in Jordan. And the wastewater of about 2,000 people should be collected and treated, and also to irrigate the surroundings of the buildings of the headquarters, but also on a big street which is in front of this police department, where you have some palms which also have to be irrigated. And the concept was given already from the police that also rainwater which was kept should be stored together with the treated wastewater for this irrigation purposes. So a combination. The wastewater here is coming in via a grid chamber and a primary treatment into a buffer. From the buffer it will be stored and then distributed on 2 lines of SBR treatment. So the waste activated sludge from the SBR systems will be brought to a separate sludge storage, and the outlet from the SBR systems here will brought to a chlorination. This was something that was demanded by the police headquarters. They wanted to have a chlorination. But I think the following presentation of Paza Razavi will tell you a little bit more about these details of irrigation. We are the ones who will treat the water in a way that it can be used for further irrigation or further reuse purposes. And you see here in the irrigation tank, there will be also let the rainwater in, so that you have always a lot, for Jordanian conditions, lot of water for irrigation. The next one is an interesting application also in Jordan in the frame of the SMART project, which was supported by the BMBF, sorry, in Germany, the Ministry of Education and Research. And it was also again a nursing home from the Sisters of the Cross, a Lebanese company, NGO. And here is interesting, they already collected the wastewater in a big septic tank. Before the outflow from the big septic tank was allowed, but the ministry has forbidden that. I will show you this in an overview a little bit later. And they planned also to extend the building here on this site, and they wanted to use the water for irrigation of gardens for fruit trees and for olive trees. And you can also imagine that when they have used the septic tank only for collecting and then the wastewater was brought to a central treatment plant in municipal. This costs a lot of money, and that's why they wanted to have a combination of a treatment and also the reuse for the irrigation. Here's the situation. This is the existing building. Here is the collection tank, and you see here a valley. And on the bottom of the valley, there are some very, very small villages where are also some wells, and that was the reason why the ministry gave no more allowance to bring the overflow of a septic tank into the ground. And here above on a hill, there are the gardens for the olive and the fruit trees. What we learned with this is that olive trees and fruit trees have a different need of water. Fruit trees you can irrigate nearly as much as you can, but olive trees also should have a certain period of scaring of water. This makes the olive fruits more tasty. So what was the reason? What was the challenge? We have here a first treatment made directly on the existing septic tank and then brought it to the gardens. Here, the situation of the existing tank. You see here the inflow. This was a 3-chamber tank here. You see the big size here. At the moment, there are 50 people living there. It should be extended to 100 people. And we have added here with our Jordanian partner a tank with 2 compartments, one for the SBR system and another one for collecting the clear water. The clear water has been also disinfected by a UV light system. And from here, you see here is a pressure line which will lead to the gardens. You will see it in the next picture here. You have an overview. Here you have the existing building. Here is the existing and the new extended tank. And here you see the pressure line which goes on top of the hill. And from here, the water will be distributed for a drip irrigation, because this was important, a drip irrigation, so we can dose the different water amount to the different kind of trees. Here's some impressions. You see here the pressure line, which is lead to this small building. And you see here the tank, which is on top for the irrigation water. This was made on top so that irrigation can take place without pumps. So this is also saving energy, so that this can be then regulated for each line. You see here, perhaps the picture is not big enough. You see here the different lines, and here you see these drip irrigation points, which could be brought into this plastic pipes. Again, here this building, and inside, to be sure that we have always a good quality and that we can avoid blocking of the valves for the drip irrigation, we have an additional treatment. This is a kind of a sand filter with a backwash possibility, and an additional UV light system that we also can recirculate the treated water, which is in the tank on top of the building. As a result of the SMART project, there were 2 typical applications for irrigation. The one which was used more often during the project was an irrigation underground or root irrigation, because there you don't need so much technology by the water treatment, but you have to look a little bit how to distribute the water underground. Here some drawings. You see here from the view from above such a distribution system. Here the trees, mainly these were olive trees, and when you look here at a cut, you see here, you will have here the kind of a pressure pipe, which is protected by another half pipe against roots to grow into the distribution system. Here you have the normal soil, but here you have also a little bit of sand. You see here wadi sand, so that you have local materials that you can use. The next one is an example for an above ground irrigation here. Sorry, Para, it's still the old-fashioned kind of irrigation here, but this is more visible. And here you have an additional treatment, something similar what I showed you in the pictures before, where you have perhaps an UV light system or a filtering system. It depends on the requirements. This is very important, that such a treatment system will be adapted to the local conditions. There's a wide range of conditions and a wide range of quality that should be brought for such irrigation or other purposes. At the end of my presentation, I would like to show you a short video which gives a summary of what I have told you a little bit, and how such a decentralized system can work in combination with an irrigation. I hope that this will start now. I hope you can see the video. Okay.
Yes, we can see.
Thank you, Christoph. There are some explanations, but I will also tell you a little bit. It starts with collecting the different water. You see here flat or apartments where the water is collected, mainly from the kitchen, from the bath or similar. Another application could be here hotels, resorts, campsites, but also office buildings similar. And for industrial applications, we have here also a farm. The water, we have to talk about a little bit later, perhaps. The whole water will come now into this SBR system here. And which is what is important here. I go back to the laser. Here, oh no, it doesn't work with the film. Sorry, with the video. You see here now the water is coming from the left, going into the primary treatment, into the buffer, and now the buffer is filling the biological reactor. The water will be aerated by a surface aerator, which produces very fine bubbles, and which is at the same time mixing. After the end of a cycle, you see here you have a decanter and a pump. The water is brought to the next step. The next step, it depends what is required and if, for example, reuse is wanted. Here you have now, you see a reuse where the water is reused for agricultural irrigation. Pasa will tell you a little bit more in detail how this will work. But there is also a possibility to store water of different qualities. Think about for irrigation. It doesn't make sense to remove nitrogen if you irrigate, for example, agricultural purposes. You can save fertilizer if you perhaps still leave it in. But there's also a possibility where you don't have water scarcity, that it will be brought to be back to the nature. Yes, this is, I think, I hope, Christoph, I was still in time and that it was not too long.
Just 2 minutes longer, but it was such a colorful and nice presentation. I assume the audience appreciated it.
This was the video.
Yes,
okay.
this was
Thank
the video.
Thank you for your patience. Thank you for your patience.
No, all fine. Great.
And here my contact data. Thank you very much for listening, and I hope you enjoyed it. And if you have any questions, please put them now or later. Thank you.
Yes, thank you, Thomas. Yeah, feel free. Maybe, Caspar, you can type in the email address of Thomas Gester for those then, in case we cannot discuss it within this tough schedule of this session, that interested colleagues can contact him straight away. Yeah, with reference to the time, thank you so much. You have shown so many interesting application cases, and even I, as a non-engineer, understood it. You already mentioned that you now pass to Pasa, so you treat with ATB the water for the different uses, and now Pasa Razavi will tell us a little bit about how he uses the water in agriculture, in fields for agriculture uses. Very briefly, Pasa, about you. You're also one of our founding members of this our irrigation group at German Water Partnership. You're managing director of IRReport. It's a consulting company for modern and sustainable irrigation systems. Pasa, you graduated in 1995 as an irrigation engineer in Iran. And after some professional years there, you continue your work as an irrigation engineer in Germany. And in the past 20 years, also with teaming up with a lot of leading industrial players in this irrigation sector. You brought this know-how to Germany by carrying out a lot of irrigation projects here. but also abroad. Thanks that you now take over the lead from Thomas and explain us what efficient irrigation systems for sustainable use, water use is about. The floor is yours.
Thank you very much. Thank you very much. Good afternoon, ladies and gentlemen. Thank you very much, Christoph, for your introduction. My name is Parsa Razavi, as Christoph told, and thank you, Thomas, that you brought me in the irrigation field. We are independent consulting to develop and engineer irrigation projects for national and regional master plan and agriculture water management. We plan and advise individual system solution for efficient fast water supply in agriculture. The head office of our consulting is close to Frankfurt, and if you are on the way in Frankfurt or you fly in Frankfurt airport, you can visit us. We can show you some reference projects or demo project, and we will be happy and to be pleasure to visit you here. One of our job is the consulting and advising and education our colleague around some countries. For example, in last year we was in Iran, in Kazakhstan, Pakistan, Uzbekistan, in a lot of countries that they have problem with water in agriculture. And we transfer our know-how, and we are happy if we can to help our colleague in our water segment and transfer our know-how. What you see is what I want to do for you now. I want to bring you in our background consulting life in water and water management in agriculture. We have a farmer, and the farmer wants to have only good quality and enough yield. But this farmer has a lot of parameter factors. For example, water, pump, soil, fertilizer, plant disease, tillage, seeds, and irrigation system. And all these parameters has interconnections. If they do something wrong, they have an influence in another side. For example, too much water bring the plant to disease, then the soil is heavy, they have to do tillage. That is complex. And we work on this complex, and we are very happy to solve this complex if we can to give the customer, to the farmer, a tools in hand that the farmer manage his watering, irrigation, and irrigation management. The wrong way that we know around the world is to plan an irrigation system. A lot of people around the world take their water resource, dams, rivers, raining, and spring, and then decide in which way we want to transfer. They transport the water. Then thinking about, okay, we give to the farmer, and the farmer decide to choose the irrigation system. Decision is by farmer to choose the right system. And the end of day is the irrigation amount according to the field. That is a little bit too expensive, because you can imagine you build a hotel, 20 floors, and you have a lot of rooms, and all people can to open all valves in this room. You can imagine what happened. They lost a lot of water. That is the same situation what we have here. We have around 15, 17, 18%, 80% of water that we lost. And this is the reason that we have very bad water management around the world in agriculture. Then the question is, we need to happen for agriculture to be sustainable. That is the most job what we want to do. Another thing what I can explain you, it is a little bit crazy. A lot of government around the world with a very huge amount of subsidies try to give to every farmer all irrigation equipment. For example, that is the picture what you see from Punjab. I was 2 years ago, and you see, for example, 6 hectare land, and in this field, you have water reservoir, irrigation, pumping, filtration, everything. And after 10 years, this disappear all. You can't find this system again. Why? Because it is a very heavy system, and the farmer has to do the maintenance, and this maintenance is too expensive. They don't have money to replace all these parts. What they're doing, they put all out and start from the first irrigation method on flooded the field. What is the right way? The right way is that we plan and design collective projects. We don't have to give the main parts of irrigation to the hand of farmer. We have to deliver the farmer. We have to clean to deliver the water. We have to clean the water in a central point. And that is the focus of our job in Germany, that we design and advise to build a collective project for irrigation community. In Germany, we have a very nice system that is very nice, that you have the culture behind this water distribution from very long term. And in another country, I saw the same situation in water management groups, that we can bring these people together. And as Thomas told, we can bring for this village wastewater plant. And after that, we clean the water. We can use a collective project with centralized irrigation and solar and everything, and bring the water in the field. It's coming now in this position to our idea in e-report. From long term, we thought, why we use very less water in greenhouses. For example, lettuce, we need, for lettuce producing, we need 0.7 liter per square quadrat a day water. The same lettuce is the same salad outside need 4 times more. And if you compare why, you will see inside the greenhouse, you have the electrical valve. Outside, you have the roasted valve. Inside, you have a very precise irrigation system. Outside, you have a very bad irrigation system. Fertilizing and this and that. And that gives us an idea how we can to manage and bring this technology outside, to design irrigation for 100 hectares, 1,000 hectares, 20,000 hectares or bigger. This is possible. This is possible if you want to do this, and we can show you how. Behind of this concept is most important. We have the crops, we have the climate, we have the soil and geology and topography and irrigation system. But the main point is in which level is our farmer and which state of the art has our farmer. How we have to be sure to give a system that they use the system, that the system is stable, and after 10 years, 20 years, we have a little bit maintenance, but not too much. We don't like to lose our irrigation system. If you check the subsidies money that we paid around the world in the last 50 years, from the World Bank, European Bank, and everything, to bring the irrigation to the irrigation management and with high efficiency of water, you can't imagine. That is a huge number. Okay, what is the right way? The right way of irrigation and irrigation management is that we start with determination of the exact water requirement of the planting culture. This is very important. But the question is, from which resource we have the data? We want to bring the data from a typical weather station and calculate the water requirement. No, it's the wrong way. The right way is that we have automated irrigation, we have a good precision of the irrigation distribution of water, then we need only less water. The right way is greenhouse or not theoretical calculation. After that, we have this rate of water, then we choose which kind of irrigation system is for which climate, correct, and which system. Then we transport the water, then we use the water resource. That is in opposite of what we saw before. And one of the very important resources is reuse. We have a lot of water that we have in Germany, in European Union, in other countries that we let to go in other fleas to flow in the rivers and everything. But the most important question is, could we use the water? Yes, we can use the water. We can use the water in agriculture. But what we have to do that we sure that this system is in a good financial situation, and how we can bring the water in the field without any problem. That is the most important in the consulting, in the planning, in automatization. What I want to show you here is very important, that you will see in the behind the manager a lot of data input. Around the world, 99% of people working of data. You have data from satellite, you have data from the weather station, or from soil moisture, and we have a lot of data. But in the end of the day, the farmer, the manager, drive the car, drive to the field, and open the valve themselves. And sometimes it's traffic, and they cannot come out to close. In this case, you will see in Germany, for example, it's raining, and irrigation work on running. What we need the second way, and that is the focus of Irrigort job. We focus on remote control irrigation system. In the past, I used a lot of parts from landscape, greenhouse, and I don't know, I can tell you a story 20 years about the automatization, which system we used. It was a hard way, I can tell you. After
2 minutes.
10 years,
2 minutes past, I just letting you know.
okay.
Thank you.
After many years, I understand, no, we need a robust system. We need a stable system. We need a communication system between the parts that stay. We need a remote control system and data. And today, I am very happy that I am in the part of German Water Partnership. And in our group, we have a lot of products. We have a lot of parts, for example, solar, we have the water use plan, endo pumps, automatization, and filter, dosing, hydraulic, and the end of day irrigation coming. A very important point for you to know, if you speak with a lot of characteristics on the market and ask them, do you have a water efficiency irrigation system? They tell, yes, we have drip irrigation. But the question is drip irrigation alone efficiency enough? Is not enough. Why? Because drip irrigation is the wheels of car. We need a Tesla. And this is the rest parts that we have from German Water Partnership members, and they build a Tesla. And that is our job. I'm happy to present you, and thank you very much for your attention.
Thank you, Parsa, showing us and the colleagues in the audience what you, how you use then the treated water from Thomas. I look at the watch. We have only 2-3 minutes, maybe maximum 4 minutes left, because quarter to, what is it then in Germany, quarter to 3, the synopsis session starts. Maybe because of that, the audience was maybe not shy, but more kind, not to write questions into the chat. But I thought it was important that you both present all your knowledge and all your experiences instead of cutting this. And maybe, Parsa, I asked one question. You have now, from your point of view as an irrigation engineer, thinking of what Thomas presented, all these well-designed solutions to treat the water. This requires investments, and I heard from you in the groups when we discuss. Yeah, we can also take the industrial water from the treatment plant, let it flow into the river, and use then the fresh water for irrigation purposes again. So, what role can your systems play here in also refinancing the treatment system of ATB and the other colleagues, for the example of agriculture?
Yes, yeah, very nice question. Very important to answer very shortly. Every drop of water that we lose costs us money. And if we increase the water efficiency, and we have automatization. We bring the water in the field, and we have a big number of hectare that we irrigate. Then we have a very better financial situation for water treat system. We cannot to produce the water in the wastewater plant with this system and lose them. And we have to distribute the water of the very huge hill. For example, if we can irrigate 10 hectare or 20 hectare or 15 hectare, the same system, then we have a better situation in the refinancing of the system. Wir hören dich nicht.
Thank you for reminding me I was muted. Thank you, Paz. I also saw here one comment of a colleague, Dirk Demand, in case you want to stay some minutes longer, you both were with colleague Dirk Demand, because I think this requires more than 1 minute. May I ask also one last question to you, Thomas? You have shown us the treatment process, and I think the most relevant part is then happened in this SPR tank. Can you tell us which kind of wastewater can be treated with such system?
Yes, it depends from project to project, but in general, you can say it is domestic wastewater or wastewater which is similar to domestic wastewater. So we're talking about, for example, food industry or similar. This is very close to domestic wastewater. What I can exclude, because we are working in these first treatment steps only with biological treatment, you can exclude, for example, heavy metal industry, where you have wastewater from chemical industry. So there you need much more technology to prepare the wastewater for such a reuse.
Thank you. So I think may then, as a final comment, just tell you what Dirk was writing. He said water demand for irrigation is not constant, and therefore the need for treated water in agriculture or horticulture or urban green will not be permanent. The availability of water and the supply from wastewater treatment plants are mostly constant. This must be considered in the planning, and other forms of use must be planned for times when application to the fields is not practical or possible.
Yes, I have a very good answer. Here is very simple. Yes, you are right. Thank you very much for your nice question. If we don't need the water, we can bring the water in the natural filtration system. And you know, Thomas, that is, we have time, you can bring the water in a high point, and then with the very natural filtration system, you can give time to the water come back in the source point again.
Thank you. So colleagues, your both email addresses, I see they are in the chat. For those of you who want to carry on the discussion and ask further questions to Thomas or Pasa, feel free, drop an email and exchange bilaterally, better tomorrow because the conference is ongoing. And also for those of you who are in German Water Partnership and has not visited our agriculture working group, you're kindly invited to join. For those who are not in German Water Partnership, but based in Germany and active in the water business, which I assume everybody of you is, feel free, become a member and join our group as well. I thank you very much for your kind attention. I thank Thomas Gesta, Pasa Rasavi, Thomas Pasa. Thank you very much for sharing your knowledge and long-lasting experience and showing us so many reference projects.
Please.
We will then see again each other in about, we have now a coffee break in about 7 minutes when I'm right for the synopsis session. Also, thank you, Kaspar, for technical hosting, supporting us, and hope to see you soon again, whether virtual or I very much hope soon also again in presence meetings somewhere on the globe. Have a nice afternoon or morning for those, or day or afternoon or even evening for those who are attending from everywhere. Thank you.